Yes, sir.
Is my voice okay now, or is it?
Yes, yes. Yes, sir.
Okay.
Now it's fine.
Yeah. Let's continue with the question. Then you will see how. Yeah.
Yes. So this was TIFR. It's actually from a sample paper.
Okay.
So the question is, P is a, yes, sir, sample paper. Yes, sir.
Okay.
So P is a cubic polynomial
Is a cubic polynomial.
with constant term 2010.
Okay.
And P has complex coefficients. So that P, yeah. So then, is it true that P has a root alpha with mod alpha greater than 10? So this is how they asked it, sir, but I think they missed out on something because trivially we can take 2010 x cube plus 2010 x square plus 2010 x plus 2010 divide by 2010, then we'll get x cube plus x squared plus x plus 1. The roots of those are 1 minus 1 I and I, so it's false.
So your polynomial was this, something like this, right?
Yes, plus 2010 x square
Okay. Plus.
2010 x plus 2010.
Right.
So roots, yeah, they all have length 1. I mean, yeah.
Then it's false.
Yeah, but I think what they missed out was that P is monic. Then, like, I'm not sure. I haven't tried yet. So then I think it's a bit more interesting.
Right. So we assume that P is.
So it's x cubed plus, or we should probably say z.
Okay. Okay, that one. Right.
Yes.
Which one? This one.
X, yes, z cube plus a2 z square plus, yeah. Oh, okay. Oh, so we can use that product of roots is minus 2010.
Right. Right. And that is the only thing that is given. Nothing else is given, right?
Yeah.
Other things are
Oh, so then
completely
we're
arbitrary.
done. So they can't. Yeah, then we're done.
How? Alpha, beta.
So alpha b. Yes, sir.
Right.
Then we can distribute it inside, like the thing, the
Right.
modulus.
Correct.
So it's actually much bigger than 10 because cube root of 2010 is the
Is
bound.
that is it?
Yeah, okay. Yes. And there was one more question, sir. This, which I think is a bit more interesting. I think this was gate, but I'm not sure. Like I've forgotten the source, but so uh so the thing is, let alpha n
Let alpha n
be the real number satisfying
be real.
p n of alpha, p sub n equal to 0.
Oh, alpha is not, it's just alpha, not alpha n.
Alpha n, yes, sir. No,
Alpha
no,
n.
no, alpha n, yes, sir.
There is, okay, alpha n.
Yes, sir, alpha n. It is
Okay.
dependent on n, yes.
Okay.
Equal to 0, where Pn of x
Mhm.
is equal to x bar n plus x bar n minus 1, all the way up to x plus x minus 1.
Okay. All are plus.
Yes, I
Last
think
one is
if,
minus.
yes, yes,
Okay.
yes, yes, yes. And now we have to find limit of alpha n as n tends to infinity. So this, I don't know how to do.
So it will either go to 0 or it will go somewhere like that, right?
Yes. So,
Yeah.
sir, like actually, so P of 0, Pn
Right.
of 0 is minus 1, and Pn of 1 is definitely positive.
Right.
Like if, like as in, so Pn is, so we have a root between 0 and 1. So a real root.
Right. Correct.
So I think, so that is our alpha n.
Huh. That's right. That's right. Right. So yeah, but so as you increase the n, you are decreasing x to the power n, but you're also increasing the number of terms. So there is a
Yes.
balance. So
Yes, sir.
yeah. So if alpha n is is this, hmm,
Okay, we might be able to use the GP.
right. So you should use the GP. Then what happens?
We get, yeah, and to the,
You get this, right?
yes, yes, times alpha n. Yes, sir.
Right. So
So this is
right.
equal to 1.
Now you can just use limits, right? No? Let us see.
Oh,
Let us see.
oh
So
yeah.
no,
Okay.
but also you're right. I mean, there is still an n there, so one has to be careful. Let's see. This is this, and this is minus
Is
alpha.
equal to, yes.
Is this right? Yeah.
So
So
how did it, yeah, plus alpha n minus 1. Yes.
right. So this will be this. Right. Is this correct? Yeah, I have
Yes, yes, sir.
taken it as. So it is just this, this.
So we can apply limits now. Left hand side will go to 0
Uh,
because
okay.
alpha is between 0 and 1. We know that.
No, but yes, but that does not mean that it goes to 0. Right? Doesn't mean.
So n is getting larger.
Yes, but if but
Uh,
it
oh,
might go to
okay.
0, but you have to say proper reason.
Yes.
Yeah.
And 1 by 2 is the answer. Like I know the answer. So
Yeah, so it does go to 0, but you have to prove it, right? So you can just
yeah,
try to
right.
prove that like maybe alpha n is less than half or something. Huh?
Yes, yes, sir.
Right. So yeah, something like that. Maybe like alpha n is less than 9 by 10 or something. You can try to prove something, right?
Yes. Yes, sir.
because you know that like if you put 9 by 10 here, right, then this will become bigger than 1 in a finite after a finite stage, right?
Yeah. Yeah.
So after
Yes,
that,
sir.
so you can forget, and after that you can say it's less than 9 by 10. Otherwise, it's otherwise it's not
Yeah.
right. So
So the
yes,
limit is 0.
then it's fine, and then but you have to. That's the
Left hand
point.
side
Here
goes to
you have
0.
to give the explanation, right? Yeah.
Yes. Yes,
So
sir.
it is the geometric progression formula.
Right. Yes, sir.
So this was you're saying some MSc exam, MSc or what?
Yes, so all these exams is GATE, TIFR, IMSC, these are all for masters.
Masters and maybe also
Yes.
integrated PhD. Same.
Yes, yes, yes. So GATE actually has masters and integrated, sorry, TIFR, it has masters and integrated PhD.
Correct.
I think IMSC also has. So it's,
TIFR
yeah,
only has integrated
masters.
PhD. TIFR doesn't have masters. But anyway, those are minor.
Okay, okay.
IMSc has I don't know SS combination. Okay.
Right. Yes, sir. So I was looking at these exams to see like
Yes.
what I
Yeah.
should
It's
expect when I
it,
eventually write them.
yes. Second, it will also give you a taste of how higher maths, how the questions are.
Yes, yes, sir. Like the ones that I can understand, I attempt because there are some that like I can do, like I can try. So like this
Yeah.
one and polynomial
Yes.
one.
And you see, you are able to do them. They are not actually difficult.
Yes, yes, sir. Oh, and yes, there was one more on this sample paper, TIFR, which I feel I should be able to do, but like I'm not getting a hang of it. I'm not getting like the trick. So A and B are 3 by 3 matrices.
Oh, sorry. A and B are matrices.
Yes, sir. And A is invertible.
A is invertible.
And yeah, then so A plus NB. So we have is A plus NB invertible or not? So there exists an integer n such that A plus NB is invertible. So true or false, we have to show that.
Such that A plus B is
Yes, yes, sir. So
invertible.
again, I think they missed out on mentioning that n is not equal to 0 because that is trivial. So
Okay. Then it's a bad
yeah,
but anyway, but I think last one was the gate. Anyways, yeah, okay. I don't.
yes, sir. So
Yes,
now,
there
like,
will be an integer.
yes, but like I don't know how to show it.
Right. So you have to. So what is happening? You have something which is an integer and something which is. Uh, so this. So do you remember? I don't know if you were there. Once we did a question that this is invertible.
Yes, yes, I was there. Yes, sir.
Yeah, if A is nilpotent,
Yeah, yeah, yes, sir.
right? So you can use something like that. Okay, so you can use something like that. So for example, you can. So first of all, it's almost like you can assume that it's almost like you can assume that the B is identity, right? Because you can do something like this,
Yes.
right?
Okay.
So it's as if B was identity, right? And also
Yes,
you
yes, sir.
can convert this n to 1 by n.
Sir, but we don't have B is invertible, so how like that A B
Oh, B
inverse?
is not. Oh, sorry. Oh, B. Sorry. Okay. I
Yeah.
thought B was invertible. Okay.
No, they haven't given anything about B.
Right. B is not. Sorry.
So what I was thinking is actually if we expand a determinant, then it will be like a cubic.
Right.
This determinant of A plus and B. So this cubic, it can have at most three zeros or 1 0.
Right.
So
Yeah.
for all
Just
other
yeah.
values of
Just
n,
okay.
it will
Uh,
be determinant will be non-zero. So A plus and B is invertible.
right. Then it's done. Right.
Okay.
Yeah.
Yeah.
That
So like
is
I wasn't sure if,
that is correct.
but
Right.
yeah,
That works.
yes, sir.
Yeah. But okay. But again, what I was thinking is right because yeah, you take the determinant and you want just an n variable. Yeah. A determinant is a very smooth condition. Okay. But I don't. Yeah. It's available to us in fine because this is
Yeah.
finite number. But I mean, yeah, if it is between infinite dimensional things, then the determinant, then you have to find an alternative, and that is what I was trying. But
Okay, okay. Yes, sir.
right. But anyways, let us see if we can just, it can be reason it without the determinant.
Right.
For example, if you convert it to something like this, and then, so then uh, you are looking at I plus this. Just one second. So
Yes.
yeah, you want to say that this is invertible for some n. Yeah. So for n equal to 0, it is invertible, right? For n equal to 0, it is
Yes.
invertible.
Yes, sir.
And
Because A is invertible.
correct, right. And then you look at this, right? Then you want to say if this is invertible. So when is this not invertible, right? When is this not invertible? So if you just consider this as a C, right?
Yes, sir.
You just consider this as a C, then you are asking when is this not invertible, right? When is this not invertible?
Yes.
So those are very interesting things, right? So when you have something like C and then this, and then you ask when is this not invertible? Okay, so
Oh, yes.
so you know that at 0 it is invertible, okay, and it turns out that the set of points lambda for which this is not invertible. Okay, so if you look at this thing, and if you look at
Yes, sir.
the set of points for which it is not invertible, that set, of course, you can show it's a finite set because again, by determinant, you have already said, right?
Yeah.
So this is
Yes,
not
sir.
invertible means it will be root. So it will have at most n values, even if it's n by n, right? But
Right.
even,
Yes.
right, but even if these are somewhat like matrices between infinite dimensional spaces, it turns out that even then, this set, you see, this set lambda, right, it will be a subset of C, right? So basically, I am
Okay.
looking at
Yes. Yes.
lambda such that this is not invertible. I am collecting those lambdas,
Yes, sir. And
right?
lambda is allowed to be a complex
Right. You
number.
can take complex numbers, right? So obviously,
Yes. Yes.
if it's finite dimensional thing, if it's just a matrix, then this is just a finite set of points. So that is not a problem. But even if it is, so that's where the magic comes. That even if this C is between infinite dimensional spaces, for example, you can consider the space of all polynomials, right? And you can consider differentiation
Okay.
as a function, Now that function is a linear function, and then it will have a matrix. These matrices are just linear functions from R3 to R3. A matrix is just something which takes a vector and gives you a vector, just a function, right? These A and B are functions. Okay. So if you replace these are functions between finite dimensional spaces. If you replace them with functions between infinite dimensional spaces, reasonable functions, then also this set, which is a subset of C, is a very interesting set. It will always be a bounded set, and it will always be what is called a compact set, meaning that it will be bounded and
Okay.
it will contain its boundary. Something like
So
that.
it's
Okay.
like a closed interval.
Is the correct, it's the analog of a closed interval, right? And if this is a symmetric
Yes.
matrix, then actually it will be a closed interval on
Okay.
R3. If it's an infinite symmetric matrix in some sense, then it will be like not necessarily closed interval, but it will be the analog of that. It could be a Cantor set also.
It will
But
contain its boundary.
yeah, it will contain all its limits, it will contain all its supremums,
Okay.
infimums, that kind of set. Okay. Now you see, if you have this kind of set, now you see, you already know that it doesn't contain zero, right? If this kind of set
Yes.
doesn't contain zero, right? If this kind of set doesn't contain zero, then it means that there will be a small neighborhood around zero also, which it will not contain.
Oh, okay.
Because it contains its boundary.
Right. Yeah.
If there are smaller
Yes.
and smaller points coming to zero, and it contains those points, then it has to contain zero also. But it
Yes.
doesn't contain zero, so it doesn't contain a small thing around zero. So here you will find those 1 by n's. These 1 by n's.
Okay. So we can
Okay.
draw small disks around
You're
zero
right,
containing
and
that 1 by.
those 1 by n's, in fact, all 1 by n's after some point will be there, which will not be there in that set.
Yeah.
Okay. But
Okay.
this takes a lot of work. Obviously, first you have to know what it means to say it's a function between infinite dimensional spaces and so on. This is a very interesting topic. Comes in something called Banach algebras. Okay.
Okay.
So Banach
Yes,
is
sir.
the infinite dimensional. Banach was a person, but Banach is the infinite dimensional
Yeah.
version of Rn. So when you're done with R2, R3, and Rn finite dimension, then you worry about R infinity, right?
Right. Yes.
And the reasonable
So
analog of
this.
R, right?
So this Banach, I know from like the Banach-Tarski paradox.
Yes, he's the same person, I suppose. Yeah,
Yes.
he did a lot
From
of
the
things.
spheres.
Right. Yeah. So yeah, those kind of things, and so basically, and it will come very naturally even in analysis, because you will be studying space R3, right? But then to understand R3, you will have to understand all continuous functions on R3. To understand the interval, you have to understand all continuous functions on the interval also. That's how mathematics
Right.
goes, right? Unless you understand rotations, how do you understand the plane without understanding rotations in there? It's like that. So understanding continuous functions on a domain, also 0, 1, you can understand. But this set of all functions is not finite dimensional, right? It is not a. So that also is a space, right? Like that's a space of functions, right? And where the points are
Right.
functions. So those kind of spaces will be coming in this Banach, that you will get when you, yeah, you will see.
Right.
It's an
Yes,
interesting,
sir.
right? And also you can see that even directly, that if you have this kind of thing, then even if you make lambda very large, it will remain invertible. That
Yes.
also you can see, make lambda very large, and also it will remain.
Right.
But
Like
anyways,
intuitively, yeah,
yeah,
makes sense.
yeah. Then it will become invertible, because you're removing all the, yes. But anyways, yeah, we can see how that's going. Okay. Because anyways, yeah, we'll see all that. Okay then.
Yes, sir.
Yeah, let us stop here. I will let you know. Maybe so. You said you are free on weekend. Sorry, evenings.
Evenings, yes, sir. Evenings.
So I will let you know if you want to stay.
Okay. Yes, sir.
Okay. Meanwhile, you continue with whatever the plan is. Yeah.
Yes, sir.
All right then.